Okay, thank you guys for keeping to this session and I appreciate your efforts. Please, if you have friends who are battling with chemistry, who who are still believing that organic chemistry is hard, come on. I don't see where organic chemistry is hard. I can't lie. For it's natural for you to feel that it's hard. It's natural, but it's unreal, seriously. After you've spent a lot of time, data, you know, attending this session, and you still say organic chemistry is hard. Well, that's that everybody has his own opinion in it. Maybe it's not hard because I don't know why it's not hard. All right, so welcome back. The next reaction before we summarize with alkynes is polymerization. Remember, I told us earlier that um, polymerization is the process whereby small organic molecule called monomer combines to form a large organic molecule called a polymer. So in ethine, it will also undergo polymerization in the presence of a nickel catalyst. Here, this time around, it's not going to produce a giant molecule. It's just a simple polymer. That's just a simple molecule. It's not even a polymer to even start with. So, but while ethene is polymerizing to produce polythene, ethine is polymerizing to produce benzene. Fantastic. Wow. So that's unique about ethine. Okay, so this is not so how do I get to remember all this polymerization something? Well, read it again. First, you read it again. Second, get the past questions and review it. Answer questions from the past question. So in that case, you will have known, oh, I think I've seen this before. You going back and forth, looking out for questions is one of the easiest method of learning organic chemistry. Another method you can do is to teach others. Yes, you can actually teach other students. Yeah, I can try explaining to other people. One of the methods I used to learn this organic chemistry is explaining to other people, especially when I was in university because a lot of students complained it was volatile, it was this, it was that. But for me, I took it as my own method of learning by learning the few I could learn, then explaining. So in the process of explaining, I now discover, oh, this is what, this is what happened. So that's another way to keep learning. Okay, so don't just stock up the chemistry into your head. It will just disappear. But if it is in an exam mode and you need to read it and you have done everything, well, just read organic chemistry last, yeah. Answer the past questions last. Don't read it too. Answer the past questions last before you enter the exam hall so that it will still be fresh and you can recognize it. So in conclusion, I always want to bring to your notice that you remember when we talked about alkanes, we said that the major reaction that they will undergo is substitution. And that one was in the presence of the nickel catalyst. In alkenes, we said that major reaction was addition, and that was in the presence of different reaction conditions. But for alkynes all the way, we've seen that alkynes undergo combustion. Everybody does that. They also got involved in addition. They also got involved in polymerization. And here again, you're also seeing substitution. So these are why would they undergo all this kind of reaction? Because they are highly unsaturated, because they contain triple bond. So what kind of substitution does it undergo? Is it normal substitution reaction like alkanes? Not really, but somehow. Here, it will undergo substitution with copper 1 chloride. It also undergoes substitution with silver triazonitrate. All of them dissolved in ammonia solution. So that's what we call it. Remember, ammonia is a solvent. So we call it ammoniacal copper 1 chloride or ammoniacal silver triazonitrate 5. So when you see ammoniacal copper 1 chloride or ammoniacal silver nitrate. Just know that ammonia was used as a solvent, not water. Okay, and so when it undergoes, look at it has replaced the hydrogen here with this is copper carbide. You can see here it has replaced the hydrogen. Very easy. Silver too has replaced the hydrogen. So how do we know that a product has been formed? It usually gives us a precipitate. It usually gives a precipitate. So silver will give us a white precipitate, while copper will give us a gray, gray precipitate. So that is what usually happen. Okay, so that is it. Now, is it all alkynes that can undergo this kind of reaction? No, sir. No, ma. It's not all alkynes. It's only when the double bond, that triple bond, it's only when the triple bond is immediately on the first carbon. It's only when the triple bond is on the first carbon. What do I mean by triple bond being on the first carbon? Let's look at 1, 2, 3, 4. Now let me put this triple bond here. That's it. Maybe yeah. Let me undo. Okay, so let me put the triple bond up. So the question here: will this compound undergo substitution reaction? No, sir. No, ma. It will not, because the triple bond is not on the first carbon. All right. So 1 minute. Okay. Let me continue. So let's see which one will the triple bond be on the first carbon. So look at here, the triple bond, let me put it here, let me put it here. So here, the triple bond is on the same carbon. So immediately the triple bond is on this first carbon, then this kind of alkyne can undergo substitution reaction, and that is what we call it. Look at it here, terminal alkynes. So these alkynes are the triple bond is immediately on the first carbon, is what we describe as terminal alkynes. So these are the alkynes that will undergo this kind of substitution reaction. Ladies and gentlemen, I want to introduce you to my last reaction I put this morning. Reaction with KMNO4. One of the methods of differentiating between alkenes and alkynes is the reaction with oxidizing agent, and that's KMNO4. But I will do that in the video. Okay, so let's watch this video to see 3 chemical ways of differentiating between alkenes, and alkynes. That's bromine. Alkyne decolonizes bromine to give a colorless solution. So Bayer's reagent, so that's called as the alkaline KMNO4. The alkane will not decolorize it. Alkenes will decolorize it to give us ethylene glycol. That's 2 hydroxyl group, ethane 1,2-diol. So you can see while alkyne will give you oxalic acid. I hope you notice the difference between the alkyne reaction and alkene reaction. So alkene will give you ethane 1,2-diol, while alkyne will give you oxalic acid. That's ethane 1,2-dioic acid. So that's the stronger method of oxidation. So alkynes are less reactive than alkenes because the carbon atoms are held together by triple bonds. So 1 sigma and 2 pi bond. Take note of that. That is UTME question. So that's the last one. Ammoniacal copper, 1 chloride. Okay, so alkane no reactions, alkenes no reactions, and of course terminal alkynes will give you reddish brown. So if it is for copper, so it gives you a reddish brown precipitate. Sometimes in some cases they give you a grey precipitate. If it is with silver, to give you white precipitate. So that's the silver one. That's Tolling's reagent. All right, so thank you very much. Appreciate that. So I've been able to put that on this table, perhaps if you need more, and that is for alkanes, alkenes, and alkynes. Okay, so one major use of alkynes is that we use them as miners lamp. Sometimes you hear of when you have to go into a coal mine, I need a lamp, so we use alkynes for such thing. But majorly we use it, um when it combines with oxygen, we use it for welding of metal. So that's one very, because of it produces large amount of heat. It was a very hot, easily controllable flame. So we use it for welding. Okay, so that's what we call it, oxyacetylene flame. I'm sure some SS3 people will have got heard of that. Okay, so it's ethynes that combines with oxygen to form what we call oxyethine. So in case they call it oxyacetylene flame. All right, so that's it for alkanes, alkynes, and alkane. So basically, aromatic hydrocarbon. I don't need to spend too much time on this. It's just the structure of benzene. So benzene is one of the major, is the major aromatic hydrocarbon. From this benzene, thousands of compounds have been formed. I mean, thousands of compounds. Um, you can see there are a lot of products here. Call it derivatives. A lot of products are here. They also talk about a lot of drugs. Yes, a lot of drugs have been produced as a result of substitution reactions in benzene. You can imagine. So what makes this benzene special? One of the uniqueness of this benzene, you can see here, it has what we call a resonance structure. This is a resonance structure of benzene where the double bond and single bond are present in a benzene molecule. You can see it's unique. And the position of the double bond is not fixed. You can see here, the double bond is in this position. Check out the position of the double bond here. Let me get it. You can see here it's between these two carbon, but here in that same position it is no longer there. It has shifted. So the electron, it is the double bonds that are present in this guy. These double bonds are made up of electrons. So the electrons keep shifting. So when they keep shifting, they now get is it now becomes a resonance hybrid, because a hybrid molecule, and that movement of electrons actually makes this benzene molecule to be strong, right? So no struggle. All right, so this is, you can draw it like this, any of them. Benzene usually have a sweet, that's why I call it aromatic, that has a sweet odor. We'll just conclude because we got 4 minutes to the end of our time, and I'm sure you have been doing wonderful well, listening and learning. All right, so I'll just clear up with this aromatic hydrocarbon. In our next session, I will try and see if I can summarize alcohols, alkanoic acid, and ester. Let me tell you, sometimes because this organic chemistry is too wide, most of the time, I could just bring maybe one question. When I mean one question, I really mean one question. It can just be draw the structure of the fourth member of alkyne. Fourth member of alkyne. So when they ask you to draw the structure of the fourth member of alkyne, so what happens? All the organic I have been reading all this while just ends. So just one question. But you have the good part of it is that it's never a waste because you have 10 objective questions in chemistry, whether it's UTME or whether it's WAEC. Okay, even the same applies to IGCSE. So for people that will do IGCSE or that are doing IGCSE, it's still the same chemistry, right? So 10 serious objective questions. So I hope you can draw the structure of benzene. First, the molecular formula is C6H6. So you connect all the 6 carbon in a ring, then you put double bond in alternate positions. Right, you know what I mean by alternate? Double, single, double, single, double, single, double, single. So that's how you draw your um, double bond. All right, so it's in alternate position. Some other person may decide to put a ring, as you see in the next pictures. You can decide to put a ring. You can see this one. I decided to put it in ring compound. I put ring. So that ring indicates that the double bonds are not in a fixed position. They are usually moving. I don't want to spend too much time on this benzene because their reactions are like only a few questions you will get. You just have to state two properties of benzene, draw the the resonance structure of benzene. These are the questions they will ask you. Number one question they will ask you, draw the resonance structure of benzene. So what will you do? Just draw these two structures. You can see these two structures, and that is all. And they can ask you what is resonance. So resonance is the hybrid between two possible structures of a compound. So it's as simple as that. So they can ask you what is resonance, you define it, you draw the resonance structure in benzene, you draw it. Then they can ask you to draw or name the benzene derivatives. So these are the common ones that WAEC has brought out in the few years, the past question. Then physical properties of benzene, yes, you can. As it's a colorless liquid, it's insoluble in water, obviously because it's an organic compound. So the boiling point is 80 degrees. So let me ask you, one kind of question can come out between in this physical property. They can just give you a mixture of benzene and what do you call and water, and ask you how can you separate benzene and water? Come on, somebody who is already thinking filtration. Come on, how can you use filtration? You can see benzene is not soluble in water. So what technique do you use to separate a mixture of insoluble solids, insoluble liquids? That's you use separating funnel. So that's the question. They cannot ask you, okay, look at this sentence that benzene is soluble in organic solvent. They not say a mixture of benzene and ethanol. Mixture of benzene and ethanol. I know that the boiling point of ethanol is 78 degrees Celsius and the boiling point of benzene is 80. So how can you separate these two mixtures? So you use what? Will you use fractional distillation or will you use simple distillation? You use fractional distillation. Please, fractional distillation is because the reason is because the boiling points are close to each other, so you can use fractional distillation. If the boiling points are wide, like 80 and 100, so that's wide enough, you can use simple distillation. But if the boiling points are close, you can use fractional distillation. So these are kind of questions you see. Obviously, benzene is a hydrocarbon, so that means it can burn. So it will undergo combustion to give you carbon dioxide and water. So what are the major reactions that they ask you? It undergoes substitution. Why? Because of the single bond. So you can see the substitution reaction here to replace each of the hydrogens. So these are some substituents. These are some products as a result of substitutions in benzene. So you can substitute with anything. So what I'll do, I'll send you these notes and you can follow and study. I don't need to stress you too much on benzene. The last question that you will see in benzene is this. You see it always coming out in JAM. He said addition. Remember benzene has a double bond and benzene has a single bond. So that means you undergo both addition reaction and substitution reaction. I've already shown you the product of substitution reaction. But for addition reaction, it will add the addition is usually with hydrogen, and it will give you one very sweet product which you call cyclic hexane. And but we don't call it cyclic hexane, we call it cyclohexane. Ladies and gentlemen, that is all. Is there any question on that benzene? Yes. State two uses of benzene. You can Google it. Obviously, I've already told you this can be used as a solvent. I've already told you it can be used. It is also used in the manufacture of drugs. I've also told you that it is used to produce many other compounds. That's how I showed you the various derivatives. So, will you say you've not learnt? Obviously, you have learnt. The time is 1:01 and we started on the dot of 12. Ladies and gentlemen, I want you to send me your topics of preference. SS1 topic, SS2 topic, whatever topic that you are having issue with, I will treat them. If you do not send, I'll just be teaching as I'm led by the Spirit, which is also a very good one. But there is no topic that is not relevant. So if you have SS1 topic, SS2 topic, SS3 topic, that you are doing, you can send and you are interested in, you can send it to me. Those of you in SS2 and you are interested in writing GCE, forget coronavirus. After the coronavirus, there's GCE. There could be I don't know if why could hold GCE, but there's will also be GCE in January. You can write GCE. Don't say let me wait till I finish SS3. Okay, so this is just my own advice to you because at least I promise you definitely with that you can pass chemistry and why. What happens to physics? What happens to maths? What happens to um, biology? If you need help in any of these subjects, physics, chemistry, mathematics, further mathematics, technical drawing, contact me. I'll, I will link you to the right kind of teachers who can help you solve the problem. Somebody have sent me one topic, said solubility calculations. I will do it. It's not a big deal. We are always good with that. Okay, so gentlemen and ladies, time is never our best friend, but I want to believe we have done our best for today. So I'll send the notes for this class right immediately after I log out on the WhatsApp section. So for those of us, last time I said, please do me a favor. If you are on the WhatsApp platform, just type your name and your location. Simple as that. I don't need any more thing from you. My name is Tochiku from Delta, from Akwa Ibom, from here. So let's just see how far we can go with this our online lesson. All right. Have a wonderful day, ladies and gentlemen. If you have questions, send it to me on what you can post your questions on the WhatsApp platform. The WhatsApp platform is strictly for chemistry and nothing more. So that's why you don't get to have any more things there. If you have questions that you are thinking, oh, I'm reading, I need to answer this question, put it on the WhatsApp platform. It will be solved and sent to you back on the WhatsApp platform. All right. Have a lovely day, ladies and gentlemen. Adios.